A barrel of oil holds 128 liters. If the density of oil is 0.803 grams per centimeters cubed, what is the weight of oil for a full barrel in kilograms? Consider significant digits. The first thing to point out is that when we talk about weight, we normally measure weight in Newton. In this case, however, we're using the old notation where people use kilogram force as a unit for weight. And sometimes, in a clumsy way, people say kilograms. The unit of kilogram is used for mass, but sometimes use kilogram force, which is still the same as mass for weight. Now, in this problem, the density of oil is given. The density, rho, is equal to 0.803 grams per centimeter cubed. And what else is given is the volume of the barrel of oil, which is 128 liters. Let's say just the barrel of oil, and the volume is 128 liters. And the density is 0.803 grams per centimeter cubed. What we're looking for, even though we said weight, is in fact the mass, which could be understood as an equivalent of weight, and therefore the unit kilogram force. Mass is found by the equation m is equal to rho times v. Now in this problem we see that the units do not match. Besides, we should notice that mass is asked in units of kilograms. So to begin with, for the units of volume we have centimeters cubed, as you can see here, and liters, as you can see here. We would convert all the units of volume into centimeters cubed into a consistent system of units. We note that 1 liter is equal to 1000 centimeters cubed. In fact, a liter is the volume of a cube which has the dimensions 10 by 10 by 10 centimeters. That's a good way of thinking of 1 liter. It's very easy to imagine. And that would give us 1000 centimeters cubed. Therefore, when I say the volume of the barrel is 128 liters, instead of 1 liter, let's say 1 liter, I can put 128 times 1000 centimeters cubed, and that would be 128,000 centimeters cubed. Now the units in volume and density are consistent. Therefore I can say that mass is equal to rho times v, which would be 0.803 grams per centimeter cubed times rho times v, which would be 128,000 centimeters cubed. Now this centimeters cubed can be thought of centimeters cubed over 1, and therefore the units of centimeters cubed would cancel out from the numerator and the denominator, and I would have as a result 102,784 grams. We need to be careful that not all of these digits here are reliable. If we look at the original data given, we note that there are 3 significant digits in 128, and there are 3 significant digits in 0.803 grams per centimeter cubed. Therefore, our problem has 3 significant digits. 3 significant digits. Besides, we should notice that the mass is asked for in kilograms. We note that 1 kilogram is equal to 1000 grams. Therefore, 1 gram is equal to 1 over 1000 kilograms. We sub this into the value we have for the mass, and we get that the mass is equal to 102,784, and instead of 1 gram, which I currently have, I will put 2784, I will put 1 over 1000 kilograms. And I keep in mind that this answer has only 3 significant digits. This ends up 102.784 kilograms with 3 significant digits only. So I would need to round this number. When I look at 78, it is closer to 100 than to 0. Therefore, I will round up the mass to 103. You can think of it as 78 cents. If you were paying $102.78 and you wanted to round it to dollars, it would of course be $103 to be reasonable, rather than $102 kilograms. And we have already considered the significant digits. That would be the final answer to this problem.